We are now covering the solutions to quiz number 3. We have a 37.3 kilogram girl and 55.2 kilogram boy. So they're standing next to each other on a frozen lake, the surface of a frozen lake. The girl pushes the boy away with a horizontal force of 5.20 newtons. Calculate the magnitude of the girl's acceleration. Okay, by Newton's third law, the boy pushes the girl with a force of 5.20, but newtons but in the opposite direction. Acceleration is the force, net force divided by the mass. 5.20 is net force. The mass of the girl is 37.3, so the acceleration is 0.139 meters per second squared. Next problem. A hand exerting a force F is pushing 2 blocks across a very smooth surface as shown. The masses of the 2 blocks are MA and MB. If friction is negligible, what is the magnitude of the force block A exerts on block B? Okay, first of all, we're going to consider both masses together to get the acceleration, because that will be necessary to know. So we have the net force will just be in the horizontal direction will be F, the force that the hand exerts, and the total mass will be ma plus mb. So acceleration is F divided by ma plus mb. Now we know the acceleration, so we can now just consider block B. The force of A acting on B, that will be equal to the mass. So that will be the net force on B, and that's equal to mass of B times the acceleration, which we know. Mass B times acceleration will be mb times F over ma plus B. So we get mb over ma plus B times F. Okay, problem 3 and 4. A mass is pulled along a rough table at constant velocity with the external force F external at some angle, theta, from the horizontal. Your friend drew a free body diagram for the system, but didn't draw the magnitude of the forces carefully, but the directions of the forces are correct. Which statement below must be true? So we know that we have constant velocity, so the acceleration is equal to 0. Let's first look in the horizontal direction. Okay, in the horizontal direction here, we have to have that the net force is equal to 0 in the x direction. So we have the external force, this component of the external force is F external times cosine of theta, minus the force of friction going in the opposite direction, so minus mu k times the normal force, n. Okay, and so, by the way, this is the force of friction. Let's call it F friction. So F external is equal to F friction over cosine of theta. Okay, but this angle is non-zero, so if I divide by cosine of theta, this will be a number less than 1, so we'll get it something that's greater than force of friction. So I get that the external force must be greater than the force of friction. Okay. Now in the vertical direction, we have this component, F external times the sine of theta. We have normal force. We have the gravity force going down. So F net y is equal to 0 because there's no acceleration. We have normal force plus F external times sine of theta, as I said, minus mg. That must equal 0. So the normal force is equal to bringing everything to the other side. These guys to the other side. We have mg minus F external sine of theta. But this is going to be some number that's positive. We are subtracting it, therefore, the normal force would be less than mg. So we get that the normal force is less than mg, external force F is greater than the force of friction. Same problem now. They want to know the correct y equation, so we've written that up here. And if F plus F external sine of theta is minus mg is equal to 0. So just rearrange the last two terms. Get n minus mg plus F external sine of theta equal to 0. Go on to number 5. Man pulls a crate of mass 63 kilograms across the level 4 floor. He pulls with a force of 172 newtons at an angle of 25 degrees above horizontal. When the crate is moving, the frictional force between the floor and the crate has a magnitude of 126 newtons. If the crate starts from rest, how fast will it be moving after the man has pulled a distance of 1.90 meters? So the idea is we're going to get the acceleration. This will be a constant acceleration problem, and then we can calculate how fast it's going at the end. Okay, F net in the x direction, so let's look in the x direction, is going to be F cosine of theta to get the x component of this force F here. Okay, so we're getting this component here. It's 172. That's the hypotenuse is 172 times the cosine of 25. Theta is 25. Minus 126 because that's the force of friction. You give that to us. That's 29.9 newtons. Now we can get the acceleration AX is equal to net force X divided by the mass. 29.9 divided by 63.0 comes out to 0.474 meters per second squared. Now we say we don't have delta t here, but we can use this equation, v final squared minus v initial squared is equal to 2ax delta x. We're told that the initial velocity is 0, starts from rest. Okay, and so v final squared minus v final squared is equal to 2 times ax, which we calculated as 0.474, times delta x, which is given as 1.90, and we get v final squared is equal to 1.8, so v final is equal to 1.34 meters per second. Next is on uniform circular motion. We want an object to move in a circle with constant speed. What kind of force should be applied? So the force must be, the net force must be centripetal force, okay, which is pointing towards the center of the circle with a magnitude mv squared over r. So the magnitude is constant. That's true. It's mv squared over r. It's not changing magnitude. That's false. The force, a force that points towards the center of the circle, towards the inside of the circle or the center of the circle. That's true. Force that points to the outside of the circle. That's false. Okay, so 1 and 3 are true. A 25 kilogram mass is connected to a nail on a very smooth table with a lightweight string 1.9 meters long. There's no appreciable friction. The tension is 54 newtons, and the mass moves on a uniform table. In a uniform circle on the table. How many seconds does it take for the mass to complete one revolution? Okay. So we have centripetal force F is equal to mv squared over r. We're going to solve for v. V squared is equal to F times r by cross multiplying and divide by m. That's 54 for the force, 1.9 for the radius, divided by the mass 25, and that comes to v is equal to the square root of 4.10. That's 2.03. Now the time for one revolution is the circumference divided by v, so 2 pi r divided by v, 2 pi times 1.9 divided by 2.03 comes out to 5.88 seconds. Next problem. The figure shows the force acting on a 2.9 kilogram object as it moves along the x-axis. The object is at rest at the origin at t equals to 0. What is its velocity at t equals to 6? Okay, so we have the force versus the time, the force in the x direction versus time. The area will give us the, under the curve will give us the impulse, or the delta tx, the change in the momentum, so just by getting this area. So this is positive area and this is negative area because it's below 0. Area 1 is 4 times 3 for the area of this rectangle. 4 here, 3 here, and that's 12. The area of this is going to be minus 2 times 2, so we get minus 4. And so delta T is 12 minus 4, which is 8 kilogram meters per second. Now, it starts from rest, so the final momentum will be 8. And so to get the final velocity, we just divide by the mass, which is 2.9, and we get 2.76 meters per second. Next problem. An object is initially at rest and explodes into 3 pieces. The momenta of the 2 pieces are shown. What is the momentum of the third piece? Okay, it starts from rest, so the total momentum has to be 0 by conservation of momentum. There's no external forces. So P3 final must be negative the sum of P1 plus P2 final. Okay, so the components of P1 final are 1, 2, 1, 2, and the components of P2 final are 5, 1, 2, 3, 4, 5, 3, 1, 2, 3. Okay, so P3 will be negative the sum of these two guys, so 1 plus 5 is 6, 2 plus 3 is 5, put the negative sign in, so negative 6, negative 5. So negative 6i, negative 5j. Last problem, a mass M1 with mass 1.50 kilograms slides on a surface with negligible friction, collides head-on with mass M2. After the collision, M1 has a speed V0 is equal to 4.10 meters per second. M2 is at rest. After the collision, M2 has speed 1.90, and M1 has speed 2.0 meters per second, but going backwards. Okay, calculate M2. So this is just conservation of momentum. Okay, they give us enough information to just need one equation. So P total, initially P total in the x direction will be just coming from M1 here. So we have 1.50 for the mass of M1, and it's going with V0 is negative 4.10. So we get negative 6.15. The final momentum is going to be M2 times negative, which is 1.90, so negative 1.90, plus 1.5 for the mass of M1 times 2.00. Okay, for the final speed of M1. Okay, so we know everything here, and so we can solve for M2. All right, and so we have negative 1.90 times M2 plus 3.00 is equal to negative 6.15, and so we get that M2 is equal to 4.82 kilograms.